Let's practice solving quadratic equations using the quadratic formula together. Now, first things first, we want to make sure we know what the quadratic formula is. So we want to try to memorize this over time, but x equals the opposite of b plus or minus the square root of this b squared minus 4ac, and then it's going to be this entire thing all over 2a. Now that I wrote it once, let's just go ahead and save this for later as well. So for number one, we have this equation of 3x squared plus 5x is equal to 8. So I'm just going to start off here and just copy down the equation. Now when we're solving using the quadratic formula, we really want everything in standard form and we want the equation to equal 0. So let's move everything to the same side. So we'll start off by just subtracting 8 from both sides of this equation. Okay. If we go ahead and do that, then we're going to get this 3x to the second power plus 5x and then minus 8, and that's going to equal 0. So now that we have our equation in standard form, we can figure out what our a, b, and c values are. So this first value of 3, that's going to be a, so a equals 3. Then we have this positive 5, so we can say that b is equal to 5. And then we have this minus 8, so we can say that c is equal to negative 8. Okay, so let's go ahead and use this information and plug it into our quadratic formula. So we have x equals, so substituting our values in here, we're going to get negative b. Now b we said was 5, so we have negative 5. That's going to be plus or minus the square root of, and let's see, we have b squared, so b we said was 5, so let's keep that 5, let's go ahead and square it. So it's going to be 5 squared minus 4 times a happens to be 3, and then we're going to multiply that by c, which is negative 8. So multiply that by negative 8. And this whole thing on top is really going to be divided by 2a, or 2 times a, so it's going to be 2 times the a value, which is 3. So we have 2 times 3 in the denominator. Okay, so let's work on the inside of this radical first. So we have this 5 squared. So going forward here, I'm just going to use the same color. So we have negative 5 plus or minus, and then that 5 squared, that's going to equal 25. Okay, and then if we go ahead and say we have this negative 4 multiplied by positive 3, that's going to be negative 12. Negative 12 times negative 8 is going to be a positive 96, so we're going to have 25 plus 96 inside this radical, and this whole thing is going to be on top of this 2 times 3, which really ends up being 6. Okay, now if we go ahead and just simplify this a bit more, this 25 plus 96 is going to be 121. So we're going to get negative 5 plus or minus the square root of 121. And that's going to be on top of 6. Okay. Now sometimes we can simplify radicals, sometimes we can't. In this case, we actually have a perfect square, right? So the square root of 121 is exactly 11. So that's a rational value. So we're going to get negative 5 plus or minus 11. That's going to be over 6. Okay, so let's take this now and continue talking about this. So we can now split this and say that there's going to be two solutions. X is going to equal this negative 5 plus 11 over 6. That's going to be one solution. And the other one is going to be x is equal to negative 5 minus 11 over 6, right? So in the first case, if we take a look at this one, negative 5 plus 11 is 6, and 6 divided by 6 is equal to 1. So we can say that x is equal to 1. And in the second case here, we can say negative 5 minus 11 is going to be negative 16 over 6. But negative 16 over 6, we can write that as this. This is negative 16 over 6. If we divide both top and bottom by 2, we can then say that x would equal this negative 8 over 3. So these would be our two solutions. All right, here is number 2. For number 2, we have the equation 5x squared plus 1 is equal to 4x minus 7. Remember, we want to make sure we know what our quadratic formula is, and let's go and rearrange this equation so it's in standard form and it's all equal to 0. So we have this 5x squared plus 1 is equal to 4x minus 7. So let's move a couple things to the left side of the equation. So we can go ahead and subtract 4x on the right side, and also we can add 7 on the right side. We can also take away 4x on the left side and add 7 at the same time here. So let's go ahead and do that. Moving everything over, we're going to get 5x squared, and then we're going to have a minus 4x. And then if we go ahead and add 1 plus 7, that's going to equal 8. So it's going to be plus 8, and this whole thing's equal to 0. Now that we have this equation in standard form, we can identify that a is equal to 5. this b is equal to -4, and then c is going to be equal to +8. Okay, now that we know that our a, b, and c values are, let's go ahead and substitute them in. So we have x equals, we have the opposite of b, so we go ahead and say that's going to be -4. Let's go ahead and put that -4 inside and plug it in. And then we have plus or minus, then we have b squared. Okay, so for b squared, again, b is -4, so it's going to be this quantity of -4, it's going to be squared, minus 4 times a. Now a is equal to 5, so plug that in as a 5. And then c looks like it's going to be 8, so we can plug in 8 for c. All right, so this is all going to be underneath the radical, and this whole thing is going to be on top of 2a, which is really 2 times +5. Okay, so first things first, on the outside, we have this -4, which just simplifies down to being a +4. So we have 4 plus or minus. And then under the radical here, let's see, we have -4 squared. That's going to be -4 times -4, which is +16. And then multiplying this -4 times 5 times 8, well, -4 times 5 is -20. -20 times 8 is going to be -160. So we're going to be subtracting 160. Okay, this whole thing is going to be all on top of this 2a, or 2 times 5, so that's equal to 10. Finally, simplifying this radical as far as we can and subtracting 160 from 16, we're going to get 4 plus or minus the square root of, and it looks like this is going to be a negative number, right? So we're going to have to deal with imaginary values. And so this is going to be -144, and this is all on top of 10. Now, when you take the square root of this -144, keep in mind that's going to be plus or minus 12i. Since we have a -144, we do need an I in there. So we're going to have 4 plus or minus 12i over 10, just because 12 times 12 is 144. Okay, so before we go any further, let's go ahead and just move this up here and then split it into two different equations. So we know that one of our equations here is going to be x is equal to 4 plus 12i on top of 10. And then we know that our other one here is going to be x is equal to 4 minus 12i over 10. Now, simplifying this top part, we can write this in standard form, writing two separate fractions, and we can divide everything by their GCF of 2. So this 4 over 10 really is going to simplify down to being 2 over 5, or 2/5. And then if we go ahead and take this 12i over 10, we can divide these both by 2, so that's going to be 6 over 5i. Okay, so that's in standard form here. And then for our other equation, or other solution here, we can go ahead and say 4 over 10, again, that's going to be 2/5, just like our other solution. And then it's going to be minus, and it's going to be 6/5 I. So that would be this second solution, fully simplified and written in standard form. Here's number 3. For number 3, we have 7x squared minus 10x plus 9 equals 5 minus 2x. And of course, let's make sure we know our quadratic formula. So let's go ahead and rewrite this equation so that we can rearrange things. So I'm going to go ahead and write that we have 7x squared minus this 10x plus 9 is equal to this 5 minus 2x. Okay, so let's move everything on the right side to the left side. So we take away 5 from the constants here, and we can go ahead and add 2x and add 2x to the x terms. Okay, so if we do that, then everything will be on the left side and it'll equal 0. So we're gonna have here 7x squared minus 8x plus 4, and that's equal to 0. At this point, we can identify our a, b, and c because it's in standard form. So a is going to equal 7, and then b is going to equal this -8, and then c is going to equal this +4. So now that we know a, b, and c, let's go ahead and start plugging it in. So we have the opposite of b, but b is -8, so we have the opposite of 8, and then that's going to be plus or minus the square root of, let's see, b squared. B is -8, so we're going to have this -8, and then we're going to square it. And it's going to be minus 4 times a, which is 7. So we have 4 times 7. And then let's multiply that by c, and c is going to be equal to 4. Okay, so we have this all multiplied together, and this is going to be all over 2 times a, or 2 times 7, because we know a is equal to 7. Okay, Okay, let's clean this up a little bit. So we have the opposite of 8, which is really just going to be 8. So we have 8 plus or minus, and then we're going to take the square root of, let's see here, we have -8 squared, that's -8 times -8, that's going to be 64. And then we have a -4 times 7 times 4. So -4 times 7 is going to be -28. And then we have -28 multiplied by 4, and that should equal -112. So we're subtracting 112. And this whole thing is going to be on top of this 2 times 7, but 2 times 7 is 14. Okay, so let's go ahead and see if we can simplify this even more. So I think inside the radical, we can do 64 minus this 112. And so 64 minus 112, that's a negative number. So we're going to deal with imaginary solutions here. So we're going to have equals 64 minus 112, that's going to be -48. Okay, now let's go ahead and take a look at this square root of -48 and see if we can simplify this radical a little bit. But again, this whole thing's over 14, but let's just focus on this radical for now. So the square root of -48, keep in mind, is going to be, let's see, we can separate into the square root of -1 times the square root of 16 times the square root of 3. So that's going to be I times 4 times root 3, or this is going to be 4I root 3. Okay, so going ahead, that's what the simplified radical is going to be. So we're going to get 8 plus or minus 4I root 3 all over 14. Now, before we separate these into two different answers, keep in mind that everything has a common factor of 2. That's their GCF. So dividing everything by 2, we can write 4 plus or minus 2I root 3 all over 7. Okay, so taking this and writing these two separate solutions out, we can go ahead and write, we have x is equal to 4 plus this 2I root 3 over 7. And then we can write x is equal to 4 minus 2I root 3 over 7 as well. Okay, now going even a little further, if we write this in standard form, we can go ahead and break this into two different fractions, right? And we can write x is equal to 4/7, right? And then we can write plus 2 root 3 over 7I. And our other solution here is going to be x is equal to 4/7 minus 2 root 3 over 7I. These would be our two complex or imaginary solutions written in standard form. Here's number 4. For number 4, we have this equation -12x squared plus 21 is equal to 0. Here's our quadratic formula, and let's see, we already have this equation written in standard form. I'm just going to rewrite it here. So we have -12x squared, and then we have plus 21, and that's equal to 0. So notice we actually don't have a b term in here. So looking at this -12, we know a is equal to -12. That's the leading coefficient. There's no bx term, so b must equal 0. That's why there's no x. It must have multiplied by 0. And then c has to equal positive 21 here. All right, so these are the three values that we're going to use for a, b, and c. And let's go ahead and plug those into the quadratic formula. Okay, so starting off here, we're going to go ahead and say we have -b, but b happens to be 0. So I'm just going to go ahead and write this in to be super clear. That's going to be -0 plus or minus the square root of, let's see here, we have b squared, so it's going to be the quantity of 0 squared. Nothing too much exciting is going to go on there. And then we have minus 4ac, so 4 times a. A is -12. Go ahead and plug that in. And it looks like c is positive 21, so we're going to plug 21 in as well. Okay, so this is all going to be underneath the radical here. And underneath, let's see, we have 2a, so it's going to be 2 times this -12. All right, so now that we've substituted in here, let's see if we can clean things up and simplify. So it looks like this -0, that's just going to go away, right? So we're just going to have plus or minus. We don't need to write that anymore. And then for the radical part, looks like we have 0 squared, which is still going to be 0. I'm not going to go ahead and write that. And let's see, we have -4 times -12 times positive 21. Well, 4 times 12 is going to be 48, and then 48 times 21, that's going to equal 1008. So I'm going to go ahead and write this as 1008 8, just like this. And on the denominator, we have this 2 times negative 12, which is going to be a negative 24. All right, so let's go ahead and see if we can break down this 1008 on the side here. So we have to figure out if this has any perfect squares inside. So I'm thinking for 1008, let me go ahead and write it like this. We can definitely divide this by 2, right? If we divide by 2, we're gonna get 504. If we divide this by 2 again, we're gonna get 252. Of course, this is even again, so let's do 2. So if we divide this by 2, we're going to get 126. I think we could divide this by 3 now, right? So divide this by 3, we're going to get 42. We can divide this by 3, so that is going to be 14. And then we can divide this by 2, so we get 2 and 7. Alrighty, so we have a lot of common factors here. So let's see, we have 3 and 3. That's going to make a perfect square of 9. So let's go ahead and say 9 is going to be one of our numbers. I'm running out of space here, so let's take a 9 over here on the side. We have a 2 and a 2, that's going to make a 4, right? So any 2 that pair up. And then this is going to be 2 and a 2, that's going to make another 4. I think those are all our perfect squares. So those are our perfect squares. Let's go ahead and put it underneath a radical together. And then we have this one extra 7 over here, so that gets its own radical. So that's the square root of 7. Okay, so the square root of 9 times the square root of 4 times the square root of 4, that's going to be 3 times 2 times 2. 3 times 2 is 6 times 2 is 12. So this is really going to just be 12 times the square root of 7. So now that we know the square root of 1008 is equivalent to 12 root 7, we can go ahead and substitute that back in. So this is plus or minus 12 root 7 over negative 24. Okay, so let's go ahead and separate this out over here. Again, we can divide this out, but I'm just gonna take my time here and say x is equal to, let's say we have 12 root 7, so positive 12 root 7 over this negative 24. And we also have x is equal to this negative 12 root 7 over negative 24. Okay, so for this top one, we have a 12 over 24, which simplifies to a half. So we can say x is equal to negative root 7 over 2. And then we can also say for our second equation here, or second solution, that a negative 12 divided by negative 24 is positive half. So we're going to get a positive root 7 over 2. These would be our two irrational solutions for this quadratic equation. Here's number 5. For number 5, we have the quadratic equation negative 2x squared plus 24 is equal to 8x. Here's our good old quadratic formula. And let's just go ahead and start by copying the equation down. So we have negative 2x squared plus 24 is equal to 8x. Now, you can go ahead and just move everything to the same side here. So let's go ahead and subtract 8x and subtract 8x to get it into standard form. But I'm also noticing here that all of our numbers here are even, so we could divide everything by 2, or specifically negative 2. But I'll do that in just a moment. So we have negative 2x squared minus 8x plus 24 is equal to 0. Right? And if you want to here, what we can do to make all our numbers smaller so we don't have to plug in as big numbers to the quadratic formula is let's just divide everything by negative 2 here. All right? If you divide everything by negative 2, we're actually going to get positive x squared plus 4x and then minus 12, and that's going to equal 0. So now we have more positive numbers and we have smaller numbers to go ahead and plug those into the quadratic formula. Notice here that we have an a value of 1, that's an invisible 1 in front, so a is equal to 1. Looks like we have b is equal to a positive 4, and then c here is going to equal negative 12. Let's go ahead and use those values now and plug them into the quadratic formula. So we have negative b, so b is going to be 4. Go ahead and plug in that 4 here. And then we have plus or minus the square root of, it looks like we have b squared, so b is going to be 4. So plugging in 4, we're going to have 4 squared. And then we have 4 times a, and a looks like it's 1, so plug in 1 for a. And then multiply that by c, which is going to be negative 12. All right, so this whole thing is going to be divided by 2a. Now it's going to be 2 times a, but a is 1, so it's really just going to be 2 times 1 in the denominator. All right, so let's clean this up a little bit. We have the opposite of 4. That's going to simplify down to just -4, plus or minus. Let's see what's underneath this square root symbol here. So 4 squared, that's going to equal 16. So that's going to be 16 here. And then we have this -4 times 1 times -12. -4 times 1 is -4 times -12 is going to be a positive 48. So we're going to write plus 48 here. And then this is all on top of 2a, or 2 times 1, and that's going to be 2. Okay. If we add 16 and 48 together, that's going to be 64. So it's going to be -4 plus or minus the square root of 64 over 2. The square root of 64 is actually a perfect square. That's going to be 8. So we're going to get -4 plus or minus 8 over 2. Okay, so writing this using two different equations here. One of them here is going to be x is equal to -4 plus 8 over 2. That's one of them. And the other one's going to be x is equal to -4 minus 8 over 2. So for this first one, we have -4 plus 8. That's going to be +4. +4 divided by 2 is 2. So we're going to get x is equal to +2 for one of our solutions. And then for this one, we have -4 take away 8, which is -12 divided by 2, which is going to be -6. So we can say x would equal -6. So these would be our two solutions. And if you notice that we did get two rational solutions here, that means that we could have factored instead of using the quadratic formula. So that might be helpful to know in the future. Here's our last example, number 6. For this equation, we have 3x squared plus x is equal to -2x minus 7. Here we have the quadratic formula, and then let's start by just copying down the equation and rearranging it so it's in standard form. So we have 3x squared plus x equals this -2x minus 7. So move everything from the right side to the left side. Let's add 2x and add 7 to the right side. So we'll add 2x underneath the x, but we'll also add a 7 as well. So if we go ahead and move everything to the left side, we're going to get 3x squared, and then we're going to have plus 3x, and then we have a plus 7, and that's going to be equal to 0. Now it's in standard form. We can say here that we know that a is equal to 3, b is also equal to 3, and c is going to equal +7. Now let's go ahead and substitute these a, b, and c values into the quadratic formula. So we have -b, and b is going to be 3. So let's put a -3 in to substitute. That's going to be plus or minus the square root of, okay, we have b squared. So that's going to be 3 squared. Plug in that 3, and let's go ahead and square it. And then -4 times a is also 3. So let's substitute that in as well. And then we have c, which is going to be this +7. So substitute that in the c value. And this whole thing is going to be divided by 2a, which is really going to be 2 times 3. All right, cleaning this up a bit, we have this -3. That's going to start out in front here. So we're going to have -3, and then plus or minus the square root of, okay, we have 3 squared. That's going to equal 9. Okay. And then we have a -4 times 3 times 7. So -4 times 3 is -12. -12 times 7 is -84. So we're going to write -84. And this whole thing is going to be on top of this 2a, or 2 times 3. And 2 times 3 is going to equal 6. Now simplifying this radical a little bit more, 9 minus 84 is going to be -75. So we're going to have -3 plus or minus the square root of -75. And that's going to be on top of 6. Now, can we simplify this radical? Sure, I think we have a perfect square inside here. So we should be able to break this into the square root of -1 times the square root of 25 times the square root of 3. The square root of -1 is I, the square root of 25 is 5, and we have root 3. So we can rearrange this to say if we have 5i root 3. Okay, so we can go ahead and write this is going to be equal to -3 plus or minus 5i root 3 all over 6. Okay, so let's go ahead and see if we can simplify this a little bit more and separate them so we can identify what's going on. So one of our solutions here is going to be x is equal to -3 plus this 5I root 3 all on top of 6. And our other one here is x is equal to negative 3 minus 5I root 3 all on top of 6. Now let's go ahead and separate this into two different fractions. So negative 3 over 6 is negative a half. These are relatively prime, so we can't simplify that part. So for this first one, we go ahead and say this is going to be x is equal to negative 1/2. That's the negative 3 over 6. And this is going to be plus this 5 root 3 over 6. That's the coefficient for I. Okay. For the second one here, it's very similar. We're just going to have x is equal to negative 1/2 again, because it's negative 3 over 6. But it's going to be minus 5 root 3 over 6I. These would be our two complex solutions for this quadratic equation. So there you have 6 different examples of solving some quadratic equations by using the quadratic formula. Some of them you could have used other methods, like maybe completing the square, or maybe even by factoring. It really kind of depends on the solutions. Like if you look at number 1 and number 5, you had rational solutions, so you could have factored, and that would have probably been a little bit less time consuming, or a little bit less writing. The ones where we had irrational solutions, so we had radicals in it or we had i's in them, that means that we needed to complete the square or we needed to use the quadratic formula because factoring wouldn't work for those. So hopefully you found this video helpful. If you did, please consider giving it a thumbs up. And as always, keep up the great work, and I'll see you in the next one.